Ever wondered how to visualize your C++ code? Imagine being able to see the architecture of your software, the relationships between classes, and the behavior of your system in a simple graphical way. Enter the Unified Modeling Language, or UML, a standardized language used widely in software engineering. UML diagrams can help you comprehend and communicate your code structure and behavior more effectively. Stay tuned to explore various UML diagrams and how they apply to C++. First, let's dive into class diagrams. These are the backbone of object-oriented modeling. They represent the static structure of a system. To put it simply, class diagrams are a visual representation of your code's blueprints. So, what exactly does a class diagram show? Well, it showcases classes, their attributes, and the relationships between them. Let's break it down a little further. A class is essentially a blueprint from which individual objects are created. It's a unit that encapsulates related properties and behaviors. In a class diagram, each class is represented by a rectangle, which is divided into three parts: the class name, attributes, and methods. Attributes, also known as properties or fields, hold the state of the class. They represent data relevant to the object. For instance, in a class representing a book, attributes might include the title, author, genre, and publication year. Methods, on the other hand, are behaviors or actions that a class can perform. For our book class, methods might include read, bookmark page, or close. Now, let's talk about relationships. There are several types of relationships in a class diagram, including association, aggregation, composition, and inheritance. These relationships indicate how classes interact and depend on each other. Let's illustrate this with an example of a library management system. In this system, we might have a class book with attributes such as title, author, and genre, and methods like checkout and return. We might also have a class library that contains a collection of book objects and methods to add or remove books from the collection. The relationship between library and book could be represented as an aggregation, as the library contains books, but the books can exist independently of the library. So, class diagrams not only give us a high-level view of the structure and behavior of classes in a system, but also illustrate how different classes interact with one another. They are indeed a vital tool to understand the static structure of a system. Next up, object diagrams. These diagrams take us a step further into the world of UML. While class diagrams show us the blueprint of our system, object diagrams bring it to life. They illustrate instances of classes and their relationships at a specific point in time, giving us a snapshot of the system's state. Let's revisit our library management system. In the class diagram, we represented book and library as classes. Now, in the object diagram, we'll imagine a specific moment in time. Picture this: a library named Central Library with a book titled The Great Gatsby. In our object diagram, Central Library and The Great Gatsby are instances of the library and book classes, respectively. They have their own unique attribute values. For instance, Central Library might have the attribute location with the value city center, and The Great Gatsby might have author set to F. Scott Fitzgerald. Furthermore, the relationship between these instances is shown. The Central Library instance might have a relationship with the Great Gatsby instance, indicating that the book is available in this library. Object diagrams allow us to delve into the specifics to see how our system would operate with real data. We can observe the interactions and relationships between instances, making the system dynamics more tangible. With object diagrams, you can capture a system's state at a specific point in time. They are, in essence, the living, breathing depiction of your system's blueprint. Moving on to sequence and collaboration diagrams. These two types of diagrams offer a dynamic perspective on the system we're designing. They allow us to visualize how objects interact with each other over time and how messages flow through the system. Let's start with sequence diagrams. These diagrams illustrate the interactions between objects in the system over a period of time. They emphasize the sequence of messages exchanged between objects. So, if we were to draw a sequence diagram for our library system, we'd represent the interactions between the user, library, and book objects. For instance, the user initiates a search for a book. The library then processes the search and either finds the book or returns a book not found message. If the book is found, the user can proceed to check it out, and so on. Each of these steps is represented in the sequence diagram in the order they occur, providing a chronological view of the interactions. Now, let's talk about collaboration diagrams, also known as communication diagrams. These diagrams depict the interactions between objects as well, but their focus is on the flow of messages. They show how each object collaborates with others to achieve a particular task. Let's say we want to represent the book checkout process in our library system. We would depict the user and library objects, and the messages that are sent between them during this process. The user sends a checkout message to the library processes the checkout, and then sends a checkout successful or checkout failed message back to the user. It's important to note that while sequence diagrams emphasize the time sequence of messages, collaboration diagrams highlight the organization of objects and their message-passing relationships. These diagrams are incredibly useful for visualizing complex interactions and message flows in your system. They help you understand how each part of your system collaborates to achieve its overall functionality, making it easier to identify potential issues or improvements in your design. These diagrams help visualize the dynamic interactions and message flows in your system. Finally, let's look at state diagrams. Just as a map guides you on your journey, state diagrams guide the behavior of an object in its life cycle, showcasing the various states an object can be in and the transitions between these states. Imagine a traffic light system. It's a simple everyday example, but it perfectly illustrates the concept of state diagrams. A traffic light can be in one of three states at any given time: red, yellow, or green. Each of these states corresponds to a specific behavior, dictating the actions of drivers on the road. Now consider the transitions. The traffic light doesn't randomly jump from one state to another. There's a specific order. From green it changes to yellow, then to red and back to green again. These transitions are triggered by a timer. In a state diagram, we represent each of these states as a rectangle with rounded corners. The transitions are represented as arrows, pointing from one state to another, usually with a triggering event or condition written above them. In our traffic light example, the triggering event could be timer expires. State diagrams are particularly useful when dealing with complex objects that have a number of different states and transitions. They help to visualize the behavior of the object, making it easier to understand and to ensure that all possible states and transitions are considered during the design phase. It's like having a comprehensive guide to an object's behavior. You can see at a glance what the object does, how it responds to different events, and how it changes over time. This can be incredibly useful not just for developers but for anyone who needs to understand the system, from project managers to stakeholders. So next time you're at a traffic light, take a moment to appreciate the simple elegance of its operation. Remember, behind every red, yellow, or green light, there's a state diagram guiding its behavior. State diagrams, a great way to model the behavior of an object. To wrap up, let's summarize what we've covered. We started our journey with class diagrams, the blueprints of our software system. They give us a bird's-eye view of the static structure of our system, illustrating the classes, their attributes, and how they interconnect. In the context of C++, we might see classes like book or library, each with their own attributes and methods. Then we moved on to object diagrams. These diagrams provide a snapshot of the system at a particular moment in time, revealing instances of classes and their relationships. Imagine seeing a snapshot of our library with various book instances, each with their own current attribute values. Next, we delved into the dynamic world of sequence and collaboration diagrams. Sequence diagrams show us the order of interactions over time. We see objects like user, library, and book sending and receiving messages in a sequence. Collaboration diagrams, on the other hand, focus on the flow of messages. They give us a clear picture of the interactions during specific operations like a book checkout process. Finally, we explored state diagrams, which model the various states an object can be in and the transitions between those states. Think of a traffic light object transitioning between red, yellow, and green. Unified Modeling Language, or UML, offers these and many other diagrams to help us visualize, specify, construct, and document our software systems. It's like a lingua franca for software engineers, enabling effective communication and understanding among team members and stakeholders. In the world of C++, UML diagrams can illuminate the architecture and interactions of your classes, helping you design robust and efficient systems. With UML, you can visualize, design, and document your C++ code effectively. Keep exploring and happy coding!